afternoon, everyone, and welcome to the latest episode of our MSME Masterclass. Today, we are thrilled to host someone who brings a rare blend of engineering depth, global insight, and a sharp eye on sustainability, Mr. Anshuman Agrawal, founder and managing director at Minimac Systems Pvt Ltd. Anshuman is a mechanical engineer from IIT Dhanbad and a certified machinery lubrication expert with over 18 years of experience across lubrication systems, fluid engineering, and condition-based maintenance. He has worked with OEMs and large industrial players to develop solutions that improve equipment reliability and plant efficiency. At Minimac Systems, Anshuman has led the charge in delivering innovative oil purification and hydraulic reliability services to various sectors including power, steel, cement, petrochemicals, and others. He also represents India as the geographical partner for Fluidtech, a global leader in clean lubrication technology, and is actively involved with leading international bodies such as ICML and STLE. Beyond engineering, he's a champion for circular economy practices and is on a mission to help Indian industries, especially MSMEs, transition towards smarter, cleaner, and more efficient operations. Please join me in welcoming Mr. Anshuman Agrawal as he helps us unpack the role of smarter lubrication systems in reducing waste, improving uptime, and building more sustainable MSME shop floors. Welcome to our MSME Masterclass, Anshuman. We are thrilled to have you with us today.
Thank you so much, and thanks a lot for that comprehensive bio about myself. I'm humbled to hear all about that.
So for our attendees, Anshuman will today take us through the lubrication intelligence for efficient manufacturing topic, giving us practical strategies. Anshuman, our first question to you today is, when we talk about lubrication intelligence, what exactly are we talking about in the context of manufacturing?
So lubrication is a part and parcel of almost all the plant and machinery as a part of any manufacturing setup. There are multiple rotary equipment and also a lot of equipment which have motion in them. Lubricants become something like a blood of all these machinery. So whenever the lubricants flow through these equipment, these plant and machinery, they have a certain purpose, and that purpose needs to be solved. The performance of all these lubricants depends on various factors. Unless those factors and those parameters around the lubricants are met, the performance of lubricants would be highly affected negatively. And hence, in order to understand the insights from those lubricants through those parameters, through those matrices, one has to implement something like a lubrication intelligence, which I must say is a very much part of manufacturing 4.0, where the entire world is moving towards. So hearing about what the lubricants are trying to say is something which I can term as lubrication intelligence.
Okay, and do you, in your opinion, do you think lubrication is an often overlooked, segment, even though it is so critical to plant performance?
Yeah, that's true, and that's an irony because something which is so critical for your equipment, as I mentioned earlier, it is nothing less than a blood of the human body. So the lubricants must get the due importance, and the criticality around them must be understood by all the plant stakeholders. This right now is an ignored, overlooked topic because most of the manufacturing setups, they focus towards production. That's a very basic human instinct that we focus towards something which is giving us short-term outcomes. And here, lubricants, the maintenance around them, the overall reliability aspects, which is encompassing the lubrication aspects, these get overlooked because these are something which will offer you a long-term benefit, and probably on a short-term basis, they would be a pullback in your plans. Probably that's the reason why in the pursuit of having a much higher level of productivity on a short-term basis, companies overlook this very important aspect of lubrication reliability, and thereby they compromise on the long-term reliability impact on the productivities.
Actually, can you also describe what poor lubrication practices typically look like on the ground in small or mid-sized units?
So during my 20 plus years of experience in the industry, I have visited multiple levels of industrial companies I have visited micro, small, medium, large, and very large industries. The one thing which I have found in common in most of the companies is poor lubrication practices. That's something because probably lubricants can't speak. And that's the reason why a lot of maintenance professionals, they probably do not take the due care of the lubricant practices in their plant premises. Lubricants are comprising of fluid or liquid lubricants. They comprise of grease oils. They comprise of various other fluids which are used for multiple maintenance and plant production practices. In any plant, whether small or big, lubricants constitute for a major impact on the maintenance budgets and expenses. At the same time, they are considered a very costly consumables for almost all the plants where they were used. With a poor lubrication practice, a company can't succeed in improving their bottom lines because the maintenance expenditures, which are mostly unplanned, they all come because of the poor lubrication practices. So in the current perspective, when we are seeing the MSME to be the lifeline of the entire industrial growth of the country, lubrication practices, in order to improve the bottom line impact of the MSME production and the MSME performance of these companies, the lubrication practices must be taken care of very well.
Now, also from your experience, Anshuman, can you tell us what kind of cost savings can MSMEs expect by improving how they manage lubrication?
So, as I mentioned earlier, lubricants are extremely costly products. Do you know why? Because lubricants come from something called as the base lubricating oil or the base oil. This base oil is mostly a mineral-based product which comes as an outcome of the crude oil refinery. Unfortunately, in India, we have just 60 to 70% of the base oil, which is right now being imported, and the rest is being domestically manufactured. So when you have a product which comes with an international impact of pricing up to a level of around 70%, certainly you need to take care of that product because this product has international pricing fluctuations and it is highly dependent upon international currency fluctuations. So that's the first and foremost impact of lubricants on the maintenance practices. Over and above this, if the lubricants do not perform their function, there would be a very devastating effect on the maintenance of the plant and machinery. So much so that the entire plant and machinery can go on a downtime or a breakdown, thereby having direct impact on the top line or the productivity of that particular machinery. Nevertheless, you also have the overall maintenance and spare parts costs, also the manpower cost which gets involved as a part of the maintenance practices. So if you can maintain the lubricants which are more proactive method, probably you would not just impact your bottom line of the maintenance activities, but also impact the top line of the overall performance of that plant and machinery.
Understood. Now tell us what happens when machines are either over or under lubricated, and how does that really affect their lifespan and output?
So lubrication is something which needs to be optimum. In any plant and machinery, optimization is the first and foremost mantra of operating your plant and machinery. When you go for any under lubrication, you mean that your lubricants are probably not performing well because they have not been chosen well. Second, your lubricants might not have the right set of parameters or their operating matrices, which are key factors for the performance of the lubricants. When you go for over lubrication, probably you are greasing your parts with too much of lubricants under the pursuit or under the myth of giving more and more lubricant, assuming it will solve your purpose or assuming that it will have a better impact on the productivity. But the fact is, lubricant have to be optimum. There are a set of lubricants which are chosen and selected by the OEMs of your plant and machinery, which are recommended as a part of your product manual or equipment manual. You need to go ahead following the strict instructions of your plant and machinery manufacturer. The lubrication schedules, the selection of lubricants, change of lubricants, or maintenance of lubricants must be done strictly according to the practices which are prescribed in the machinery which you are using in your assets and your plants.
Okay, and is there a way for MSMEs to assess whether their current lubrication approach is effective or not?
So yes, there are multiple ways of auditing your overall lubrication practices. The first and foremost thing is you could form a special cell within your maintenance department, which is an expert in understanding the lubrication needs of various machineries. There are certain certified professional courses which you could always assign to your manpower in your plant who are a part of the maintenance teams, so that they could understand much better facts and understanding about the lubrication aspects. Also, there are certain tests and some online monitoring methods by which you could assess the performance and operational matrices of a lubricant performing in your machinery. Nowadays, condition monitoring and preventive maintenance practices around condition monitoring have really come up very well at a much economical spend. So the MSMEs can always adopt these practices, thereby they could save a lot of money for their bottom line improvement and also for their top line improvements.
Now tell our attendees, according to you, what are some early warning signs that a lubrication system is falling short before it leads to a complete breakdown?
Right. So this really is a very good question because it gives an impact on the historical evidences by which you could actually perform the root cause analysis of a machinery which has really broken down in the recent past. So when you do these RCA analysis and you carry out the trend monitoring of the various operating parameters of the lubricants and the systems, you actually come to understand what are those signals which were already available with us through which we could have predicted the performance of a lubrication system. Through these studies, it has been established very well that there are certain parameters like lube oil analysis and lube oil parameter monitoring, vibrational analysis, thermography analysis, sound analysis, ultrasonic analysis. These are certain parameters to be observed and monitored under reliability practices through which one can hear what the machines are going to say or what the machines actually are undergoing. There is a sequence of understanding the signals. There is a sequence of understanding the signs or the indications which are thrown from these machineries through which, as a part of the entire reliability practice, any company can establish a methodology or an entire practice of predictive maintenance within their plants.
Now, if we talk about smaller teams, according to you, how can these smaller teams set up an efficient lubrication schedule that is not too complex for them to manage?
CFTs, cross-functional teams, is something which will help out very largely out here. There needs to be one driving force which can be a reliability professional in the organization, and that person or that single person department can drive CFTs within the company who would be ending up implementing such practices. But the need of giving a management importance towards reliability aspects is very important. So while the implementation will happen bottom to top in the organization, the mandate, the will, and the intentions have to come top to bottom.
Okay, now Anshuman, also tell us, for MSMEs using steel-heavy machineries, how does lubrication affect performance and wear over time?
Lubricants have multiple functions, but reducing friction, eliminating any wear and tear possibilities is the primary function of a lubricant. If we take some real-life examples of some industries, for example, there are certain rotary equipment like turbines, compressors, engines, gearboxes, and pumps. In all of these equipment, there is a shaft, there is a bearing, and there is a relative motion between the shaft and the bearing. In these bearings, you use lubricants for reducing the friction and having a smooth performance of the bearings. If the lubricants do not perform well, there would be a direct impact on wear and tear of the inner race of the bearing. Also, over a period of time, there would be a direct impact on the shaft outer race, because of which the overall plant and machinery might go on a lesser performing efficiency, and over a period of time, they might have to replace those parts. Again, over a long term, these can be extremely costly affairs, and hence, by small measures of condition monitoring of lubricants in these rotary equipment, alongside solutioning of the condition monitoring practices, is extremely important to be implemented by the companies.
Now, a question that we often face from our attendees, and we've heard this a lot of times from a lot of people that we've interacted with, is are there any affordable digital tools or sensors that can help even small units track lubrication needs in a company?
So yes, the answer is we do have a lot of digital tools, sensors, and these are also today integrated with certain IIoT gateways through which you can send the sensor data into a cloud. You can have a software built for reading those data, performing a machine learning activity on them, and then providing you artificial intelligence related insights. So a lot can happen when you have this availability of sensors and a lot of data. But the question is, do we require to implement it in a certain machinery? The answer would be quite dependent upon the criticality of that machinery. So if a particular plant has a machinery or a lubricated machine which is highly critical for their production, which is extremely costly towards expenses on maintenance, or is also consuming certain lubricant which is extremely highly priced, or it is something which is imported, then probably it makes real sense to go for certain digitization and the sensor technologies. Otherwise, there are offline tests available for measuring the parameters of the lubricants, which can be established as a common pooled facility for either a single MSME company or maybe in a cluster of multiple MSMEs in common. Today, the government also promotes certain labs which become a cluster head lab for multiple MSMEs around that geography. So such practices could always help you in identifying the condition of the lubricants so that necessary insights can be drawn and the decision making around the next action can be taken.
And Anshuman, do you recommend using general purpose lubricants, or should MSMEs invest in application specific options only?
See, lubricants are a formulation. A typical lubricant is formed by 90% of base oil blended with around 10% of additives. These additives are chemical formulations which impart certain functions, properties, life, and functionality to the lubricants. So if someone goes for a general purpose lubricant which is not recommended for their equipment, probably the performance of the equipment would be highly affected. Yes, there are a lot of lesser critical applications where the MSMEs or even the large scale companies certainly can go ahead with general purpose lubricants. But there are a lot of critical machinery where the functionality of lubricant is highly specific. In those circumstances, it's always advisable to go for the appropriate grade and the appropriate make of lubricant, because probably it would have the necessary formulations within them. Just an analogy out here, we have a lot of generic medicines around in the market which do help us in the regular diseases and illnesses. However, there are a lot of critical illnesses and diseases where we would need a specific dose of medication, and also certain times certain brands and certain formulations. So with that comparison, you could always understand how lubricants work and what kind of selections we must do across lubricants.
Also, Anshuman, how do factors like dust, heat, or moisture impact how well a lubricant works in real shop floor conditions?
I must say that's a very important factor. If the ambient conditions are bad, this is something which is not as per the design. The design of any equipment or the lubricant happens assuming that the entire world around it is clean. No one would be able to do an assumption on how dirty the environment is, because that's case to case. That depends upon the area where the machinery is operating. Certain industries are highly dusty, for example, the mining, materials handling, port, and certain industries would be highly clean because the nature of that entire industry is like that. For example, pharmaceuticals or textiles. So depending upon the ambient conditions, the amount of foreign contaminants which would enter into the lubricant tank or the entire lubrication system would be varying a lot. If your conditions are prime and they are completely clean in nature, probably the degradation of lubricants would be less. However, if the conditions are adverse, you might land up changing your lubricant every now and then, and thereby the cost of running the machinery would be high, the cost of change of lubricants would go high. So as given those examples, yes, today the mining industry, the port industry, they are the highest users of lubricants, and they keep on changing the lubricants every month or so.
Perfect, got it. Also, Anshuman, can you share a real-world example with our attendees where poor lubrication directly caused a failure of production downtime?
Well, I have hundreds of such cases, but I would limit myself with sharing of just one or two of them. So I have a case which I remember from one of the power plants of India. Certainly, I can't name it because of confidentiality reasons. So what happened is this power plant has a certain lubricant which costs somewhere around 2,500 rupees per liter. Yes, you heard it right. It's 2,500 rupees per liter. Naturally, because it's a synthetic lubricant, the general mineral-based lubricants are just 100 rupees per liter. So this one is extremely costly. Also, the criticality of this application was very high because this lubricant affects the overall running of that turbine. The turbine is the main equipment of a power plant. So it's something like the governing system of a power plant. If this lubricant doesn't perform, the entire power plant would go on a shutdown for certain hours or maybe days. So here, this lubricant has a contamination class or acceptance level of extremely high purity level because the criticality is high. Because of the dust scenario in a power plant, this lubricant gets dirtier very fast. Also, it has a very peculiar property that it will attract the moisture from the atmosphere extremely fast. It has a certain affinity with moisture. So because the moisture starts entering from the atmosphere into this lubricant, the lubricant starts getting some reactions. And these are oxidation and degradation reactions of that lubricant. Over a period of time, moisture and various solid contaminants in the lubricants, they establish an oxidation reaction which over a period of time will degrade and decompose that lubricant. Thereby, there would be a lot of sticky particles which will come out. And because of those sticky particles, the entire plant and machinery would not be able to perform. So this is a very strong example of how this critical lubricant gets dirty with the contaminants in the surroundings, because of which the lubricant loses its properties, it decomposes into various fractions, and ultimately it has to be replaced again and again. Also, not to forget, during the period it has brought about multiple breakdowns and shutdowns for the purpose of changing of parts and the lubricant itself. Over this entire duration, the power plant would have lost a huge amount of production and also would have spent immensely on the maintenance expenditures through purchase of spare parts and lubricants. I had estimated in one of the cases the overall impact of poor lubricants practices in that power plant was surmounting to somewhere around 40 to 50 crores because of the downtime and the breakdown related expenses.
What kind of SOP, according to you, or SOPs or documentation should MSMEs maintain to ensure proper lubrication practices?
So, there are a lot of good practices they must follow. It's not just one single document SOP, but that would be a complete plant level or an organizational level improvement which one has to undergo. If I talk just about SOPs, probably there would be some very few bullet points I can tell you, but it is an elaborate practice which has to be implemented across all the departments. Some SOPs are, which I can give as just as a tip. If you store the lubricants in barrels, you cannot store them upright. They have to be stored on a 9 o'clock, 3 o'clock basis so that your lubricants do not capture the humidity of the atmosphere while they are in the storage areas. Second, you need to have separate dispensing pumps and dispensing equipment for various lubricants that are used in your plant so that you can avoid any form of mixing of the lubricants. Also, you must always have a shed or covered storage for the lubricants in the plant, because if they are exposed to the rains and various environmental concerns, the storage also might lead to contaminants in the lubricants. Always use the best purification systems or reconditioning systems for your lubricants even while they are in the usage in your plant and machinery, because the various plants and machineries which you have, they would have limited methodologies for maintaining the lubricants. You would always need certain external reconditioning systems which can be used for performing the repair of the worn off lubricants. So just some of the tips, probably it will be helping you a lot.
And also, are there any standard KPIs to track the effectiveness of lubrication and maintenance practices?
So for lubricants, as I was mentioning earlier, there are certain operational matrices. If I may tell you just the 5 most important ones, the first would be viscosity of the lubricant. Every lubricant comes with a certain level of thickness, if I may call it in the layman's language. So it's the viscosity as a parameter which is extremely important for the lubricant to be maintained within the 10% range of the standard lubricant viscosity. The second important fact is the solid particle contamination, which is measured in terms of NAS 1638 or ISO 4406. It's basically the amount of solid particulate contaminants in the lubricant. It's a size versus number of particles matrix, which is ultimately reported in terms of a number, and that number is called as NAS or ISO 4406. The third parameter can be the moisture level in the lubricant. Moisture is measured in parts per million, because in terms of percentage it would be few decimal percentages. So normally one has to maintain the moisture within 500 ppm for most of the applications, and certain critical applications less than 100 ppm. Moisture can impact directly the chemical decomposition of the lubricants, and hence moisture maintenance within the recommended limits is extremely important. The fourth criteria can be total acid number, which defines the amount of acidity in the lubricant, through which you can also ascertain whether the lubricant is undergoing some oxidation reaction or not. So if you see some acid content increasing from the initial levels, you could always understand that the oxidation of the lubricant is happening, and that's the reason why the acid number of lubricant is also going up.
Okay. For our MSMEs, can you also tell us how can they move from manual lubrication routines to more intelligent or rather semi-automated setups?
Right. So any plant would have multiple machineries, which are lubricated machineries. You could always categorize them into 4 different sections. The first and foremost can be the most critical equipment, and so on. You can go down as lesser critical, medium scale critical, and least critical. This A, B, C, and D categories can be defined based on the facts like the direct impact on productivity of the plant, cost of spares if that equipment fails down, availability of spares, in how many days you will get that, or availability of manpower which you will be requiring for solving the breakdowns. And the last one can be the cost of lubricant that you are going to incur. All of these factors, when combined together, you could always figure out which are your highest criticality equipment and which are your least criticality equipment. Implementation of intelligent lubricant practices through IIoT based sensors can be done for the top criticality levels of your machinery. And so on and so forth. You could go with semi-automatic and manual methods of testing of lubricants, through which you would be performing a condition monitoring practices of the entire plant and machinery. So here I can say that intelligent lubricant practices start from condition based monitoring and thereafter implementing solutioning around these condition monitoring practices. Solutioning means if you have a problem which has been identified as a part of your condition monitoring practice that needs a solutioning around it. If there are certain contaminants which were found in the lubricant, they need to be removed, and thereby you would be achieving a clean lubricant for your all the plant and machinery over a longer period of time. Thereby the benefits would be you're not just increasing the lifespan of the lubricants, but also increasing your lifespan of parts, your machinery, and the overall production efficiency of your complete setup.
Let's move on to the sustainability part of it. Can you tell our attendees, is it possible to recycle or reuse lubricants safely? And moreover, is that something you would recommend for MSMEs to do?
The 3 R's for sustainability and circular economy, as we know, are the first one, repair and reduce. The second one is reuse. And the third is recycle. Today, there are multiple methods by which any company can perform repair and reduce aspect of the circular economy. How they can do that? If they are implementing the condition-based monitoring practices, they would be able to repair the lubricant whenever it is going bad. By doing that, they are going to prolong the lifespan of the lubricant. They are going to avoid the lubricant change frequencies. So then they are reducing the generation of waste lubricants within their plants. Today, there are also certain practices by which you can reuse the lubricants by performing some higher level of repair activity on them, and you can reuse them for the lesser critical applications. Also, as a part of circular economy initiatives by the Government of India, the recycling of used lubricants has become a mandate today. It is a part of the EPR initiatives by the government, under which every company is mandated to ensure that the waste lubricants coming out of their plant is ensured to go into a recycling collection cycle, and after that it needs to go into a re-refining plant, and the output of the re-refining plant needs to feed back into the circular economy of the lubricant sector. So it's not just our responsibility, but now it has become a mandate in India to ensure that we are undergoing a circular economy practice in lubricants. So in today's scenario, burning the lubricants, throwing off the lubricant into your sewage, or using the lubricants to just pass on as an effluent into the rivers is something which is completely uncalled for. Also, it has penal action by various enforcement agencies. So whether it is an MSME or a very large organization, practices of sustainability, waste management are highly implementable on the lubricants. So you can't avoid that ever now.
Also tell us, what kind of training would you recommend shop floor teams to receive to avoid common lubrication mistakes?
For the management and for the supervisors, there are multiple trainings which I have mentioned earlier are certified professional trainings. These are training related to the best practices of lubricants in a plant, testing of lubricants and establishing a condition monitoring program for your company, and also the solutioning around these monitoring practices. Through these trainings, you can always upgrade your entire management staff of the organization, whether it's the lower management or the middle or the top management. Then the shop floor team members. For the shop floor team members, you need to define, there are no certified programs as such in the industry, but company to company, a lot of these trained professionals, they would have to establish the SOPs on how to manage and maintain the lubricants at the shop floor level. This is a practice or something which has to be implemented over a period of time. One has to perform this through cross-functional teams. It is not just one separate department which will be responsible for managing the lubricants, but the entire shop floor, whether it's production or maintenance or reliability or any other department, they need to be well aware on how the lubricants need to be handled.
Also tell us, in your opinion, how important do you think is maintenance, procurement and operations team to work together on this?
Yes, so you caught my words. CFT is something extremely important here. And if you involve all these departments together, everyone is upgraded towards the knowledge of lubricants, the significance of better lubrication practices, and its impact on better productivity. And hence a CFT, a cross-functional team, is the answer, which can be driven through a lubricants reliability department or a cell, and they need to appraise all these stakeholders onto the same platform in terms of understanding the importance of lubricants and the handling of lubricants. The procurement teams also become extremely important here, because when they take the decisions around the purchase of lubricants, they need to understand the significance of selection of lubricant. If the selection is incorrect, probably the lubricant practices would go haywire. So even the procurement team members, they can't really go with the least priced lubricant procurement, because lubricants come for a specific purpose. They have a certain function, they have certain formulations in them. Unless and until you are following all of those, you can't just go ahead with the least priced lubricant or a generic lubricant for all your applications. So one stick doesn't solve all the problems. You need to have a very strong understanding of the application and the formulation which will help your application for the lubrication needs.
Now, my last question to you, Anshuman, is if someone were just getting started with lubrication intelligence, what are the 3 steps that you would recommend to them first?
So here the 3 steps, or rather I would give 3 different practices which one has to adopt. The first one would be to educate. The second one would be to monitor. And then the third one would be to solutionize. So with these 3 things, you could always establish the best lubricant practices in your plant. And trust me, the amount that you invest in these practices are going to come back to you in multifold levels, because they are going to help you save your bottom lines and they are going to improve your top lines.
With that, we've come to the end of today's episode. Anshuman, thank you so much for being with us and for sharing your detailed insights on lubrication intelligence, and also sharing such critical practices with our attendees. And I'm sure they're going to learn a lot from you and your data points that you shared. Thank you so much.
Thank you. Thanks a lot.
For our attendees who are online, if you'd like to view the current episode, if you've missed any part of the current episode, please go on YouTube, type JSW1 MSME, and you'll find all the episodes uploaded there. Thank you once again. Bye-bye.
Thanks. Bye-bye.